Well, we're going to continue graphing, and we're going to continue graphing by plotting points. But remember, I'm only doing this so that you can see connections that's going to make your graphing easier in the future. So in this next video, this video right here, I'm going to be graphing, but I'm going to be illustrating an easier way to do it. So remember that plotting points not super efficient. I will show you how to do that, but I'm really drawing a connection with how these numbers interplay to this graph. So I'm kind of teaching it before I'm teaching you here. Now, you're going to notice one thing about this. It's real hard to plug in values for x if you don't have your function or your line solved for y. So one of the things that we want to do if you're forced to plug in points and you want to figure out some ordered pairs here, if you're going to have to do that, please solve your equation for y. It makes your life so much easier. Then we can pick some values for x and we can plug in and solve for y. Now one question I always get asked is, well, can't you just solve for, do you always have to solve for y? Can't you just solve for x and plug in values for y? Yes, you can, but it gets tricky on your ordered pairs because what's going to happen is our horizontal axis is always the first number in the ordered pair. That's always the x. Even if you plug in for y and find x, your x has to come first. Your horizontal axis is always the first number in the ordered pair. I am not going to show you that in this video. If you want to, that's up to you. You can solve this for x and plug in for y, but I'm warning you right now, be careful on your ordered pairs. The number you plug in, if you plug it in for y, still has to go second. Horizontal axis, first number, vertical axis, second number, no matter what variable you solve for. Now, so to keep things kind of cohesive, kind of the same ideas, we're always going to be solving for y. Most people are going to solve for y all the time. And the reason why is because that puts us in a really nice format for something called slope-intercept later. I've alluded to it, but that's why we solve for y. So let's try that. Let's solve for y so that we can plug in some values for x, get our ordered pairs already in order. The table's going to look really nice for us. And then I'm going to go backwards, and I'm going to show you how to go from here to here without plugging in points. It's going to be awesome. Now, if you remember how to solve for a variable from solving linear equations, the same exact techniques work here. We're trying to isolate y. We're trying to get y completely by itself. So use the same techniques. Use the get rid of the terms connected by addition or subtraction first. Remember, we'd have to use subtraction or addition to do that. We're trying to get zeros with addition subtraction. Then divide to get rid of the number in front of your variable. So if we're trying to solve for y, the first thing we're going to do is remove anything connected by addition subtraction. Means we're going to have to get rid of that 2x. How do we get rid of it? How do you remove an entire term? What number are you trying to get? Remember, the number you're trying to get is the number that you can add to something and get back that something. So we're trying to get here zeros. We're trying to get zeros. We're trying to remove the entire term 2x, and we're trying to get zeros. Let's subtract it. If you subtract 2x, notice that 2x minus 2x is 0. That's exactly what we want because there is the additive identity. 0 plus 3y, that 3y remains. So we maintain that. That's awesome. Now, on the right-hand side of the equation, we talked last video about keeping things in order. I still want you to do that. So let's keep this in order. What I mean is I don't want 6 minus 2x. I want negative 2x plus 6. This creates a 0. 0 plus 3y still gives you 3y. On the right-hand side, let's put these in order. The x term first. The constant second. Now look at it. Is that isolated? If you were solving this in a linear equation and you said, hey, I solved for y, would you be correct? Have you actually got y by itself? Not yet. You have 3y. You still need to get rid of that 3. Now, please watch. Please get this right. Please don't miss this. When you divide, because you're going to have to, this is connected by multiplication, and we know the only way to undo multiplication is division. We're trying to get ones now. We're trying to get ones next to our y, because 1 is the only number that you can multiply by your variable and get your variable back. So we're trying to get 1. How we get 1 is we divide by 3. Now we're going to do that to both sides, but be careful over here. I don't want to see the whole thing divided by 3. What I want you to do, very, very, very much like multiplying both sides by a number, that number goes to every single term. You're going to divide both sides by that number. Every term gets divided by that number. So yeah, we're going to divide by 3. When we're adding, subtracting, you're getting zeros. When we're multiplying, dividing, we're trying to get ones. That's a multiplicative identity. It gives you back your variable. But when we do divide it, I want to see that you're dividing every single term. With your linear equations in 2 variables, that should be 3 terms all the time for us. Unless we're missing a constant, then it's only 2 terms. On the left-hand side, hey, that's exactly what we want. 3 divided by 3 is 1. 1 times y is y. On the right-hand side, let's create this, let's take from this fraction and create a fraction in front of our variable. If you remember, I hope you remember, if you remember, we took that variable from before and we moved it to the numerator. Now we're basically taking the variable from the numerator and moving it behind the fraction. And the only reason why we're doing that is so that we can easily identify, it's called the slope, so we can easily identify the coefficient in front of x. So I don't want to see the negative 2x over 3. I'd prefer to see the negative 2/3 x. And then we have 6 divided by 3. Conveniently, that's a whole number. We get plus 2. I want you to pause right now and work your way through that example again. Do you understand how to solve for y? If you do, that is awesome. If not, go back and watch the linear equations, the solving linear equations. We're using the same stuff. Get rid of stuff connected by addition via subtraction. You're trying to get zeros here. 2x minus 2x is 0. 0 plus 3y gives you back the 3y. Lastly, divide by the coefficient of our variable. What that does is it creates ones. 1 times your variable gives you back your variable. So we're kind of switching what we want, whether we have addition or multiplication. We want zeros for addition. We want ones for multiplication. Remember to divide every single term by the same number. Whatever that number is, whatever gives you 1, divide everything by that number. Now, this is a little easier to plug in numbers to. Could you have done it here? Yeah, you could, but it's going to take you a little bit of time to solve. Essentially, you'd have to go through this exact same work every time to solve it. So let's solve it once and for all and plug in all of our numbers to this. That's the idea. Could you have solved it for x? Yeah, I would explain that. So let's find some points from that linear equation, 2 variables. As you're going through it though, oh, do you remember last video? Do you remember what we did? Is that solve for y? That's awesome. Is your x term first? Yeah, you betcha. Do you have a constant? Do you remember what that does? If you don't, stop right now. Go watch the last video. Do you remember what that does? Do you remember what that tells you about where this line, and it's certainly going to be a line, diagonal line. Do you remember where that crosses the y-axis? Do you remember that? Because we're going to plug in a number in just a second. We're going to plug in 0, and by plugging in 0, this whole term's gone. So we're going to plug in 0, and it's going to give us 2. This line is going to cross, I can't hold it in, man. I can't hold it in suspense. It's awesome. This line is going to cross this y-axis right there. It has to. That 2, that positive 2, is that 2. That is where that comes from, because when you plug in 0 for x, it puts you somewhere on that y-axis, and that's the only number left. It's the last man standing. After that, do you remember what this tells you? That negative 2/3. Do you know whether we're going to be climbing or whether we're going to be falling? What do you think? Do you know what that negative 2 tells you? Would we be going up or down? What's that 3 tell you? Would we be going left or right? It's always right. Let's find those points and let's see how this works. This is the part where we go kind of quick. I would encourage you to do this on your own. I would encourage you to pick 0, not 1. Not 1. Don't plug in 1. Please don't plug in 1. We talked about that last video. You're going to plug in some points that kill your fraction. So we plug in 0 because that kills a fraction and that creates our y-intercept. Definitely 0. If we plug in 0, hey, this negative 2/3 times 0 is 0 plus 2 gives you 2. You immediately have an ordered pair, 0, 2. I just spoke about it. Don't plug in 0, don't plug in 1, don't plug in 2. Plug in your denominator. That will always get rid of your fraction. So we plug in 3. What other number would we plug in? Probably not 4, probably not 5, but multiples of 3. So numbers like 3, 6, 9, 12, multiples of 3, multiples of your denominator in general is what lets you simplify that fraction. So we multiply 3 and 6 by negative 2/3. Try in your calculator, do it in your head if you want to. Let's plug in 3. Negative 2/3 times 3 gives you negative 2. Those 3's are gone. Negative 2 plus 2 is 0. So that gives us a 0.30. Let's plug in 6. Negative 2/3 times 6, let's see, the 3 and the 6 simplify, it's going to give you 2. So negative 2 times 2 is negative 4, plus 2 is negative 2. This should give you the point 6 comma negative 2. Let's plot them. So we already knew about this guy, this 0, 2. That's fantastic. Then we have a point 30. 1, 2, 3, 0. We also have a point 6, negative 2. 6, negative 2. Looks like it's about right there. Does it look like we did it right? Do we have a line like we thought? Have you looked back at your slope and said, hey, that line should be going down from left to right, decreasing? Yeah, of course it should. That says you're going down 2/3. Let's look at the interplay once we graph this line. I want you to see how these numbers work here. I also want you to see that in order for us to easily find the slope, this is big, don't miss it. In order for us to identify the slope, you have to be able to solve for y. There is no other option. You have to solve for y to see how that line climbs or falls. At least the rate at which it climbs or falls, the rate of change. The rate of change is the slope. So we have to be able to solve for y to find that slope. It's a big deal. Let's graph our line. Let's look at what it does. And let's see if those numbers that we think are going to affect our line the way we think. Probably should go back and label that as our linear equation there, that y equals negative 2/3 x plus 2, or the original. But check it out. Once we've solved for y, are you seeing it? Are you seeing how nice this makes it? Because you can look back at those numbers and see everything about the line right there. It's kind of cool. This says we should be crossing at 0, 2. That 2 is on the y-axis with the x-coordinate of 0. Plug in 0, you get 2. Here's 0, 2. That number is that number. It says we should be dropping. That negative says falling, 2. 1, 2. And then going to the right, 3. 1, 2, 3. Down 2, 1, 2, right 3, 1, 2, 3. It's the same. It has to be the same. That's how lines work. It's like a staircase. It's like when you're walking down, you want your stairs to be all the same height and run, all the same rise and run. And that's what slope is. That's what it's giving us. Does it make sense? If it does, awesome. Stick with me here. If it doesn't, you go back and watch the last couple videos, because I start to explain it in those videos. The other thing I want to show you is that this is all, you're going to love me. If you don't already, you're going to love this. Love this. Check it out. I want to go back to here, and I want to show you magic. Seriously, magic. You see, there's different forms of lines, of linear equations, for different reasons. This form is awesome. If you have it given to you as y equals, you're not going to change it. You're going to graph directly from this. Remember, my goal in this is to get you away from plotting points. I don't like that. That's slow. That's inefficient. Graphing from here is very quick. Go up 2, drop down 2, go right 3. You're done. Just 2 points. That's awesome. If you want 3, you can keep on going. But check this out. If you have an equation in this form, it's called standard form. Standard form is when all your variables are on the left and your constant, if you have one, is on the right. Watch this. This is fantastic. And I'm going to unpack this. Yeah, I know that it's the lessons in the future videos, but I want you to start thinking about it now, because I don't want you relying on points. It's slow. So we're going to pause for a moment. I just want to think about it. Do you remember what every coordinate along the y-axis is as far as x is concerned? Do you remember that? Every single point along the y-axis has an x-coordinate of 0. What that means, and I know this is old stuff because I've talked about it, but what that means is if you plug in 0 for x, you will find the y-intercept. You have to. It's the only way it works. That's kind of neat. Actually, that's exactly what we did here. We plugged in 0 for x, we got the y equals 2. There you go. But wait, there's more. What's the y-coordinate of every point along the x-axis? So wait, oh, that's a different question. Every x-coordinate here is 0. 0, y. Every y-coordinate here is also 0. It'd be x comma 0. So every single point on the y-axis is 0 comma the y. Every point along the x-axis is the x comma the 0. Here's what that means for you. If you want to find the y-axis, or y-intercept, sure, plug in x equals 0. But you can do the same thing to find the x-intercept. Plug in y equals 0. Now, this is going to seem like magic, but this is cool. Let's use that backwards. Check this stuff out. If I let x equals 0, check it out. Check it out, it's awesome. If I let x equals 0, it basically covers that up. I call it the cover-up method. It's called the intercept method. It's a little bit later. But if you plug in x equals 0, that's 2 times 0. That's 0. That is gone. It's completely gone. All you're left with is 3y equals 6. That's it. Can you solve that? It's pretty nice. Divide by 3, y is 2. Wait a minute. You just plugged in 0 for x, and you got 2 for y. That, ladies and gentlemen, is an ordered pair. That's the exact same thing as that, 0, 2. It's not a coincidence that we plugged in 0, we got 2, that this 2 is that 2, and that we plugged in 0, we got 2. Wait, that's exactly what we've done. It's just we did it quicker here. Now check this out. What about y equals 0? If you plug in y equals 0, that remains, but 3 times 0 is 0. So essentially, that term is gone. 3y, well, y times 0, or 3 times 0, that's 0. We'd be left with 2x equals 6. Solve that one. X equals 3. But wait, that's an ordered pair. Now get it in the right order, though. X's come first. That would be an ordered pair 3, 0. You got 3 for your x, you got 0 for your y. What the? Yeah, that's 3. That's 3, 0. This is called the intercept method of graphing. So method 1 is plotting points. Method 2 is intercept method. What I'm trying to build in your head is that there are relationships between standard form and your x and y intercepts, and they're very easy to find. Cover up your y, you find your x-intercept. It's right here. Y equals 0, x-intercept would be 3, 0. Cover up your x, you find your y-intercept. X equals 0, your y is 2, 0, 2. That's your y-intercept. That's kind of neat. So at this point, you should be feeling pretty okay about graphing by plotting points for sure. But now start asking yourself these questions. Do you understand how the slope causes you to go up or down? Do you get that? Next one, are you seeing that by plugging in 0 for x, we're on this axis, and by plugging in 0 for y, we're on this axis. And if we use that to our advantage, plug in x equals 0, y equals 0, we find our x and our y-intercept. That's awesome. How many points do you really need for graphing? You really only need 2. And there's our 2 points. That's super cool. We're going to do something very similar there. What I would encourage you right now to do is pause this or do it right now. I want you to solve that for y. It shouldn't take you long, and then find some points to plug in. Yeah, this is plotting points. I'm going to show you how to do that, and then we'll make the jump to how the slope interplays and whether or not the intercept method works for that. So let's do that now. If you want to solve that for y is not by itself right now. I need to get rid of this negative 2x. Remember, with addition, I want to get zeros, not ones. I want to make this negative 2x into 0. That's going to require me to add 2x. So negative 2x plus 2x, that's 0. I want that because 0 plus y gives me back my y. On the right-hand side, we want the order. We want our x terms first and our constant terms last. So I'm going to write this as 2x minus 1. Stop right now. Ask yourself, could you identify if this is in y equals form, or if this is solved for y? Is it solved for y? Yeah, we don't have to divide. That's fantastic. We get y equals. What's the constant? What is the constant at the very end of the problem? Do you know what that tells you? Right now, could you put your pencil on where you think this line is certainly a line, where this line crosses the y-axis? Could you put your pencil there? Because you always take a negative, or you take the sign with that term. The number at the very end of this is negative 1. We darn well better be crossing the y-axis right there. You plug in 0, you get negative 1. That's cool. Now, we don't have any fractions, So I'm not worried about the points we plug in. The only time we worry about the points we plug in is if we have fractions, then we plug in the denominator or the multiples of denominators. I would for sure plug in 0. That's awesome. What happens if you plug in 0, by the way? Plug in 0 for your x. 2 times 0, 0. 0 minus 1 is negative 1. Exactly like we thought. That's kind of cool. We know right now that we have a point right there. It is no coincidence that that negative 1 and that negative 1 are the same number. That's why they're the same numbers, because you plug in 0. The next one we plug in is something like 1 or 2. You really should have already done this on your own. If I plug in 1, hey, 2 times 1 is 2. 2 minus 1 is 1. So we're getting the point 1, 1. That's right about there. The last point, let's plug in 2. 2 times 2 is 4. 4 minus 1 is 3. So we get 2, 3. That's right about there. It looks good to me. I know that I'm going up. I'm going up. Interesting. I'm going up. It looks straight. I don't have any points way out of whack. So I'm going to draw my line. I normally label it, so we'll probably label this thing as y equals 2x minus 1. And then we see the connections. Are you seeing it now? It should be starting to really click. I hope it's clicking for you. That negative 1, we have this solve for y. This negative 1 tells you, cover up the x, just like before. Plug in 0 for x, just like before. Says you're crossing the y-axis at 0, negative 1. From there, hey, that number in front of x literally has to tell you how you get from point to point. Not origin to point, from the point to the point. So you start with the y-intercept. And this says you would go, what do you think, up or down? If that's positive, up to, since we made a fraction, the denominator is 1, right 1. Up to, right 1. Up to, right 1. The whole way through. Your slope is positive or negative? If your slope's positive, you have to be climbing from left to right. Now, the next question I get asked is, well, wait a second. How can you make that method that I showed you right here? Could you make it work for this? Absolutely. Now I'm going to ruin the suspense. The only time this method doesn't work is if that number's 0. That's the only time it doesn't work, because then you divide 0 by 2 numbers and you get the same number. You get 0 twice. That would be a problem. So let's look at it real quick, and then we'll do one more example. I'd like you guys to do it on your own and then kind of tune back in. But let's take a look at this one. Let's say you're lazy, like me. I don't want to solve for y. I don't want to plug in points. There's certain methods for certain forms. If your function or your line is already solved for y, you win. You got slope and you have an intercept. Boom, you're done. If not, if you have standard form, your variables are on one side and a constant on the other side, you win anyway. Because if you think about what we just talked about, if you want to find your y-intercept, your x values would all be 0. Plug in x equals 0. If x equals 0, your 0 is gone. That's gone. Negative 2 times 0 is 0. 0 plus y, y equals negative 1 when x is 0. That's what that says. 0 for x, negative 1 for y, you're done. That's your intercept. Notice how little work we did. This is 5-second graphing, guys. Okay, what if you wanted to find your x-intercept? Well, wait a minute. On the x-axis, all your y values are 0. Every one of these points has a y value of 0. Let's plug in y equals 0. If you plug in y equals 0, that's gone. Then negative 2x equals negative 1. Yeah, we have to solve that. Yeah, you're going to have to make a 1 out of this by dividing. Divide by negative 2. X would equal positive 1/2. Please remember, negative divided by negative is a positive. We get fraction. What the fraction? You get fractions. We've graphed them already. It's okay. You can get fractions out of this. This just tells you that on the x-axis, where your y is 0, your x-intercept, your x value has to be 1/2. That gives you an ordered pair 1/2, 0. Here's 1/2. That's 1/2 0. It's the same exact points no matter how you do it. It has to be. It's the same stuff, guys. Whether you plot points or whether you use slope intercept or whether you use the intercept method. Right now, I'm basically teaching you all of graphing at once. I know it's a longer video. That's okay because we're going to start unpacking each of these methods later. And if you get it now, later's going to be easy, like easy, easy. Again, the main ideas here are we're getting away from plotting points. We're finding two methods that work awesomely well. If you have your line, your linear equation solved for y, we have a method for that. If we don't, standard form, we got a method for that too. So the reason why we learn two other methods is because they work for certain cases and we don't want to have to always go back to one thing. That we're saving time right now, saving a lot of energy. I'm going to put one more on the board. I'd like you to try it completely on your own. Try solving for y. That's a big deal. You need to be able to do that. Plug in some points and then see the slope and the intercept. See the intercept method like this if you can. That's what I want from you. Of course, I'll go through the whole thing and then our video will be over. Okay, get started as I erase the rest of this board. I want you solving that for y right now. Now, please focus here real quick, okay? Just because I'm teaching you other ways to do things doesn't eliminate the necessity for you to know how to solve for y. That's a big deal. So we're going to solve this for y for sure before we do anything else. Okay, you should have already done it. We're going to kind of go pretty quick through this. If we solve for y, you would need to subtract 5x. You're trying to make zeros. You still have a negative. Watch your signs. We're putting our terms in order. That's a big deal. And if you want to get 1 by dividing, you will have to divide everything by -4. Huge point here. Negative over negative is a positive. Negative over negative is a positive. That fraction is simplified. You leave it as a fraction. Positive divided by negative is a negative. You write minus. This right here is going to give you your y-intercept and your slope. I would encourage you to make some points here. The points we would make, I'd plug in 0. You always plug in 0. I'd plug in 4, and I'd plug in 8. Those are the points we would plug in. 0 is going to give you -5. 4 is going to give you 0. 8 is going to give you 5. Those are the 3 points that we would graph right now. Now, I'm cheating because I want to show you the connection. You plot those points, you're going to be A-okay. But I gotta show you because I can't just leave it as you plotting points. This is a much better way to graph. Or the intercept method. Check this out. If you understand the connection, once you solve for y, this -5, that is, plug in 0 for x, that is your y-intercept. Shoot, it even shows it right there. Your slope from there, look at this, look, it says go up 5, 1, 2, 3, 4, 5, and go over 4 to the right, 1, 2, 3, 4. That's your next point. Look, it's on your graph, you found it anyway, but this makes it faster. This literally is your line. All you need is really 2 points with these methods. The 3 points was to check you to make sure your math is right when plotting points, but you really only need 2. If you did the intercept method, you can make it even quicker. From right here, cover this up. 5x equals 20 if you plugged in y equals 0. X equals 4. That gives you the point 4, 0. Plug in x equals 0. This is a careful one, be careful. You get negative 4y equals 20. Divide by -4, that's huge. Y equals -5. That's 0, -5. And that's exactly where that point comes from. That's the way that we make graphing very quick. I want you to practice that before the next video. See if you can understand between the points and the other techniques I've taught you.